All right, everybody. Welcome to Einstein webinar. And for today, we're going to talk about Solid H. As you can see on the screen, here's the software. I'm using 2020 version, and I think the 2021 version will come out soon, around the middle or end of this year. For the following few webinars will all be about Solid H. I think we will cover, the plan is to cover part design, simulations, generative design, and of course reverse engineering, which is I think most of people's purpose on using this software with scanner. So let's get it started. So for today, we're going to be talking about part design, which is kind of like a basic because, for reverse engineering, it's actually kind of another way to do part design. It's part design based on a reference, which is your model. So this part design section will be a good base for all of the operations you can do in Solid H. So please pay attention to it. Okay, let's get it started. So as you can see on the screen, here we have is a kind of a mover. It's kind of an electric tug machine, help you moving things around. If you don't understand what it is, I think we have a picture of it. So yeah, basically it's just a power tag, help you to move things easier. Okay, so I don't know if you noticed already, I bring up this large assembly machine. It's for kind of a little background introduction about what we're going to do today. So you see this mover, it's actually missing one small part. As you noticed already, here we have a hook and here we have a center shaft, but we are missing one connecting piece which connects those two bolt holes and connects the fork here to the center shaft. And today for the part design section, I'm going to walk you guys through the process to design this part. Alright, so let's get it started. Okay, so to design the part, the first thing we have to do, of course, is to start from a new part. So what we're going to do is we go to the top left. You can see there's one button called application button, and just click on it. And here we have all the menus for the software. What we're going to do is we'll click on new, and we're going to start a new file. So here you can see that Solid H actually providing a lot of different standard templates, such as ANSI inch, ANSI metric. Of course, we have ISO or JIS. It's all different standards. For this time, it doesn't really matter, but based on what kind of standards your work's going to be in, you can select different standards. It will give you different annotations on your drawings. So isometric parts. Remember, you click on the select the parts, not draft or assembly. Otherwise, it's going to be different. Okay. So let's start a new part. Click on OK. Here you can see our windows. I think we should talk about this interface first, so you can know where to find all those functions. So the first thing I want to say is looking at the bottom where we have a search in place. Here is where you can find all those functions if you don't remember what it is. For example, if I want to extrude, this is just type it in, and it will help you find the way to do extrude. Okay? And then the interface layout is mainly similar to all those Microsoft Office software. So if you are familiar with like Word, Excel, or other Microsoft Office software, you are familiar with this layout. So they have different tabs on top for different function groups, and here all the ribs give you different functions. You can see we have home, which is mainly the most used functions. Then we have specific sketch, 3D sketching, 3D surface. PMI is the annotations, dimensions. We have simulation tab, generative design, reverse engineering. Also 3D print, which I think they have some of the useful functions. For example, I know there's one thing that bothers people a lot is when they use CAD software to generate a design with a thread hole on it. When they wanted to 3D print it out, they find out that all the thread holes are just a normal round hole. Here under 3D printing tab, we have physical threads, which will help you to generate an STL file with real physical threads inside, which I think is a pretty useful function, help you to print it out the final useful product. All right. We also have inspections, help you to get for example, the center of the mass, or you can measure point-to-point distance, things like that. And they have different tools. For example, you can generate pictures using KeyShot. Okay, and they have a building data management function. Okay, so today we're going to mainly focus on this home tab. I'm going to walk you through all the functions here on the tab. All right. So this is for the menu part. Then we go down and look at the window from the left to the right. Okay. So first you have all the tabs for different parts, assemblies. You can click on it to go back to the assembly that we saw before. And also here is a list of the features. It actually contains all the information about the product, the part you would design. It has materials, it has 3 bases. You also can bring up the base reference point just by clicking on the box to check it. So you'll see the 3 planes in the base reference coordinate system. All right. And here you see synchronous. It will give you a list of the synchronous features. We're talking about the synchronous, the meaning of it later. And on the left, we have a couple of tabs for different functions. For like we have feature library, so you can design kind of a template for different small features. For example, I can design a small thread hole, which is a standard hole, and by using it multiple times, I can store it in the parts in the feature library and bring it up easily. And we have other different dialog viewer you will be find here. And on the center, of course, is the design space, and on the right bottom, we have this cube, help you to find the view. All right, you can click on any of the elements to go to that view. And of course, you can click on home to go to the home view. All right. And this promote bar is kind of a small helping tool, tell you what to do now, or when you are starting different functions which you don't familiar with. For example, click on drawing a line. You will see that the promote bar will tell you what to do to create a line. Okay. All right. So far for the interface introduction. So next step, we're gonna start it. All right. There's one small thing before that, which I want to introduce about the synchronous technology, which I think is kind of the soul of this software. It's what makes SolidEdge different comparing to other software like SolidWorks, which they use, actually we call it order technology. So what's the difference? The difference between synchronous and order is that when you were in order technology design software, you were actually drawing the features one by one in a history-based tree. So on the left, if you're using SolidWorks, you will see that you have sketch, you have extrude, then maybe another sketch, another extrude. Everything are built one by one in an order. So if you change something on the top of the list, you might have effects on the later features. And if you change something on the bottom, there's nothing to do with the features on the top of the list. So everything has an order of it. And for synchronous, it's actually different. So all the features are like the way we call it, it's all synchronous. So everything are on the same page, same level. They are kind of independent. So if you even change something that's made, like for example, on the first step, you don't really have a lot of impact on the later of your design. They will all be automatically changed. So it's easier for you to change your design, or I'll say the really good scenario is that you want to change others' design, because I was a designer before and it's really a pain in the ass for me to change someone else's design parts. I really don't have an idea on how the drawings were made because I didn't draw the shit. I didn't draw the thing. So for synchronous, it's easier for you to change. It gives you more freedom. And I think you will understand what I'm saying when we were finishing this part. You will see the advantage of synchronous technology. Okay? So for design this part, the first step, of course, are similar to what we did before in the other CAD software like SolidWorks. So you have to make a drawing, which is kind of like a base. So you can go from 2D to 3D by extruding. So the first thing we're gonna do is we draw a sketch, and doing that we need to select the drawing functions. Here we're gonna draw a circle first. You can either click on the top. Here we have the draw sections, or which I think is also a useful function, is that they have a right-click wheel. So if you right-click on anywhere, hold it, you will see this wheel come up, and you can select different functions. This quick access wheel is actually customizable, so you can change all different functions, put it on. Like if you use other functions a lot, you can customize it, put it into it. So let's try circle. And once you have your draw function selected. Next thing you want to do is you want to select your plane to lay down the drawings. The way to do it is either you move your mouse to the plane and you will see it's highlighted. Then you should click on this plane lock sign, so that you are locking to the plane, or you see this F3, so you can either click on the lock or press F3 to lock to the sketch plane. This gives you advantage that you won't be drawing in different space, different planes, because it's a 3D space. So it will help you to lock onto this certain plane, and all the drawing will be within this plane. Next thing you want to do is you want a drawing view. So you can click here sketch view, or you can click Control H. Let's move to the sketch view. Lay down this circle from the center of the coordinate system. And we'll give the diameter to 50. Okay. Then we're going to draw this rectangle also from the center. Alright. Now we're gonna put some dimensions onto them. This one, where it's set to 50. Then the width, how about 25? And the total length could be 100. So you see that even you are using synchronous technology, everything are driven by dimensions, so it's accurate and you can control on all the sides easily. Okay. So once you have all these have this drawings down, you will see that all the enclosed regions are painted in light blue. It actually means that the software is detected a single area, which you can, it's enclosed area, which you can do either extrude or other different functions by selecting those enclosed sketch area. Alright. So now we want to do extrude for the whole thing. You can either selecting those areas one by one, or you can actually just draw and drag. To select all of them, like this. And after you select them, you will see that here we have a small arrow popping up. It's actually helping you to do extrude. So click on the arrow, you can extrude this drawing, this sketch easily. Let's give it 34. Now we have our base settled down. You will see that all the dimensions colors are changed, because before there were dimensions for sketch, but now after you draw a solid part, all the dimensions are migrate to the 3D parts automatically. So now they are 3D dimensions instead of 2D sketch dimensions, and they were detached from the sketch. So this is why I said synchronous technology gives you more freedom, is because once the part is down, the drawing, the sketch is actually detached, so that you don't need to change the sketch to driven your parts. Your part is driven by 3D dimensions instead of a drawing. You can even delete the sketch, and there's nothing to do with your parts. It's still there, and all the dimensions are still there. Okay. As I said before, the solid edge, it's really easy for you to change your design parts at any time. So even if I already selected the sketch, I can still change. For example, let's say I want to change the length of it to be down to 80. I can easily just click on the number here and just turn it to 80. Alright? So all the dimensions are actually, all the model are actually driven by 3D dimensions, which you can easily change. Alright? And a way to the other way to modify the model is just by clicking on for example, I want the right side of this here to extend another 50 millimeter. You can just click on the right side of the surfaces. It will be highlighted and then that arrow will be popped up. And you can actually click on the arrow and drag it to change it. Well, you notice that actually both sides are moving when I was dragging. This is because here you can see this design intent window. The software is guessing our intent, and it's thinking that since we draw the base sketch with rectangle by center, it's guessing that all these two surfaces will be symmetrical according to the base system. So since we only want to change one side, which want to break this symmetric relationship, we can uncheck symmetric, and now you can change only one side of it. Alright? So let's give it 50 millimeters here. Now it's extended by 60 millimeters. Okay? And in case you want to learn more about design intent, you can actually click on this. It will bring you up a short video about how design intent works. You can watch it later by yourself. Okay? Basically, design intent is kind of a way for you to maintain all the relationships while you change the model. We started up with a sketch on the reference plane. Actually, in college, you can draw a sketch on any plane, either on the model. So, for example, let's draw a line on the top surfaces. Same thing, you move your cursor to the top surface, press F3 or click on the lock to lock onto it. And then you can lay down this line. Since we want the line to be horizontal, you can actually putting out some other relationship to it. Here on the top, click on horizontal or vertical. Make it vertical like this. Alright. So this line actually breaks the top surface into two different regions. You can see if you move the cursor onto it, it's actually already divided. So for a region, you don't need a full enclosed sketch. All the sketch and all different edge are actually included to the region recognition. So you can click on the region, and now you can click on arrow to either drag down and cut it into the parts, or drag up to build a full part. So we want the total height to be 150. Actually, the base part is already 34, so we can minus 34. Press enter. Okay, so we have the side down, and next I think we want to add some round to it. Okay, so you just click on the edge to select the edge that you want around. Let's give it 15 millimeters. And also these two edge. Notice that you can actually select those edges that's not as actually hidden on the back side of the model. Let me give this to 40. And 50 to these two. Also, here on the pop-up option menu, you can actually change different way to select the edge. Like you can select all the fillets like this, or you can actually select all the rounds. Let's give it to 2. And for example, if you're not sure that what's a good number for your rounds, you can actually put in a number. For example, I put 1. I want to see if it's good. I can click on tab instead of hitting enter to confirm. Hitting tab is actually giving you a preview of the dimension you just put it in. So 1 is too small, 2 looks good. When you feel like it's good, you can press on enter to accept. Alright, all the rounds are down. So what if you forgot to put in the dimensions into Sketch like I did before? I only draw the line but didn't put any sketch into it. You can actually put in 3D dimensions onto the model directly. So for example, I want to change the dimension of the distance between this point to the back. I can just click on Smart Dimension. And let's move here. And we can keep 45. Just like this. Okay. So you can adding 3D dimensions anytime you want, even at the places that round has already been done. Okay. So next, we're gonna adding some cutout for the center shaft hole and some clamp mechanism. So let's draw some more sketch. First, a circle. Let's lock to the plane and go to sketch view. All right. The center hole. Give it 34 millimeters. Next, let's draw 2 rectangular for the cutout. Okay, you can snap to the side of it here. Then also another one here. So if I wanted these 2 slots to be the same width, you don't really need to adding up sketch relationships at this level. You can leave it different at the sketch level, and then when we build it up, you can use different face relationships to make them coplanar or things like that later. So far we can go with this sketch. Alright, let's do extrusion. Let me just select them. Select all the regions that we want to do extrusion and click on the arrows. You see that the default is actually adding material. We actually want to cut material on different both directions. So first we want to you can either here click on symmetric and change extrude, cut or add material on the option bar, or you see on the bottom promote bar is best tap shift to toggle symmetric and space bar to change the add or cut setting. So click on shift. Now I'm doing on both sides. And if you click on tab, you can change to cut material or add material. So let's cut through it. All right. And then like I promised, I wanted these two slots to be at the same width. So let's just add some face relationship. This time we will use coplanar. Okay. You click on it says click on the element to relate. This is the one you want to change. So I want the right one to be the same width to the left one. So I click on the right one first, and right click to confirm. Then click on element to position the selection here. You notice that now they're at the same width. And also, I think you also notice that I only coplanar one side of them, but actually both sides are changed. This is based on the symmetric design intent that we had it before, so it's easier. This design intent is easy for you to keep all the relationship all together. Okay, next we're gonna add more dimensions onto the model itself. Let's go to bottom view. The first thing we want to do is that we want to change the center shaft diameter, not diameter. We want to add some tolerance to the center shaft hole. So since it's a shaft hole, so it could be a little bit larger, but the lower tolerance should be 0. So you see that the 3D dimension, not only you can putting on dimensions, you can also putting on tolerance onto it. Okay, by just clicking on the dimension itself, you add the tolerance. And next, we're gonna add more dimensions to it. Since we didn't control the model by the sketch, not this one. Okay, here. And this one to be 34. And this one to be 25. It's actually changing on the side that we don't want. So you see when you were changing the dimensions, here you have 3 different options. You can set the driving end to be the left end, right end, or the symmetrically both ends. And in our case, I want to keep this 136, so I want to change on the left side. Okay, so click on the left end and type in 25. Now you only change on the left side. Okay, and finally, let's change the width of the center hole. course, we want to be symmetric. You'll find that when I'm changing it, the width of the whole thing is also changing. This is because of design intent. We have some different relationships, like this offset here. So we want to break out this offset, so we can change only the center hole. So you notice that when I'm changing only one side of the slots, both slots are changing. This is because we already have this coplanar design intent and symmetric design intent here. Let's give it 8. All right. There's already a lot of dimensions. If you feel like there's too much dimension in your view, you can here uncheck them to hide it. They were still there, but just hide it. Okay. So next, there's another thing that we're gonna do a lot is making a hole. You can either click here or in the right bottom wheel menu, click on the hole. After you click on it, here on the option bar, you can change the whole options. You will notice that there are 5 different types of holes that you can make, and you can do thread hole, tap threads, or all different kind of holes. So this time we're going to do a simple one. Let's do M10. You can change different standards. Okay. And you can change how you want the hole to be. This time we will do through all. Okay, we will lay down the hole at the center of this round, like this. All right. And the next thing we want to do is that we want to pattern it. So keep it selected and click on the rectangular pattern. And we will do a 1:7 pattern. And the total distance should be 120. Here we go. The next thing we're going to do is we'll show you the real advantage of design, the synchronized design technology. Is that we want to filter this right side of the handle about 5 degrees around this hole here. This will be kind of like a mission impossible if you're using other design software like SolidWorks, because you will need to change a lot of different features and change the different sketches. But in Solid Edge, it's really just a small, simple action that you can do easily. So let's do it together. First thing you want to do is you want to select the place, all the features that you want to filter, like this. Okay? Make sure you didn't select this round, otherwise when you tilter it, the top surface will be changed too because they are all connected. Okay? Then now you will see this wheel pops up. It should be automatically attached to the center of the hole if you select it right. If you see this wheel to be somewhere else, just click on the center of it like this and just move and attach it to the center of this round. Okay? Then now we just click on the wheel here and you type in 5 and enter. It will just give you a 5-degree tilter easily like this. Okay? This is kind of the most amazing advantage of synchronized technology, giving you unlimited freedom on changing the design you made at any time. Okay, so far is what we have for part design. We already worked through nearly all the functions here that we have. Let's do a small conclusion. So here you have all on the home tab, here you have all the sketch functions you can do. You can trim, you can draw circles, line, rectangles. Then you can add relationships to the drawings, the sketches, like what you did in other CAD software. Okay. And here we have the smart dimensions, where you can add dimensions to either the sketch or to the 3D model itself. And here we have all the solid functions. You can put on rounds, put on holes, we already talked about. You can extrude, you can make a box. You can add rough to the surfaces, as you can see. Then also you can do thin wall. So Solid give you a lot of different instruction videos and tell you what the function does. And also, this is unique for Solid Edge, is you will be able to add face relationships onto the 3D model to have more control onto the model that you made. And of course, we have orient, and we can do patterns, we get different view settings. All right. So this is how you made a part. You can try to play this video several times and try to do this part with me and see how it works. Hope you enjoy it. Thank you.